Objective, the distributive property. Definition number 1, a term is a number, a variable, or the product of a number and one or more variables. So a term could be 5, just a number, a variable, x, or it could be the product of a number and one or more variables. So it could be 5x, 5xy squared. These were all examples of terms. Definition number 2. A constant is a term that has no variable. So a constant is basically just a number. There's no x, there's no y, it's just a number. So 13, negative 12, pi, any of these that are just numbers without variables. Definition number 3, a coefficient is a numerical factor of a term. It's the number that comes before the variable. So the number in front of the letter. So if I have 5x, the coefficient would be 5. Definition number 4, like terms. They have exactly the same variable and exactly the same exponents. Variables have to be the same, exponents have to be the same. So, for example, 3x squared and 4x squared. X and x, the variable is the same. To the second power, exponents are the same. So these are like terms. X to the first power, y to the first power. Remember, if you don't see the exponent, there's a little 1 there. So 1, 1 here, those are the same. They both have x to the first power, they both have y to the first power, so these are like terms. Down at the bottom, 6, 5, and 3 are all coefficients. They are the number in front of the variable. Okay, it's a numerical factor of the term. And 12, or you could call this negative 12, is a constant. There is no variable here. It's just the number. These 3 are not like terms because this one doesn't have a b. This one doesn't have a squared. This one doesn't have a. So these all 3 have different variables. The distributive property. For every real number a, b, and c, so a, b, and c just represent numbers, you can do these 4 patterns. If I have a times the quantity of b plus c, then what you'll do is you'll say a times b plus, because there's a plus in the middle, a times c. Or if there's a minus in the middle, a times b minus a times c. Now we write them side by side because a times c is the same thing as saying ac. Now these 2 and these 2 are just flipped. A is on the back side of the parentheses instead of out front where it was before. So b times a is ba plus c times a, which is ca. b times a, ba, minus c times a, which is ca. Now let's plug in some numbers since a, b, and c do represent numbers. Example 1, 5 times the quantity 20 plus 6. So this will be 5 times 20 plus 5 times 6. Or if 5 was written after the parentheses, you'd say 20 times 5 plus 6 times 5. Both of these are going to give you exactly the same answer. Example 2, 9 times the quantity 30 minus 2 will be 9 times 30 minus 9 times 2. Or if 9 is written on the right side of the parentheses, 30 times 9 minus 2 times 9. Example number 3. So 3 and 4 show you why we would use the distributive property. It allows us to do mental math instead of having to rely on our calculator. So 34 times 102, that I can't do in my head. But I can break down 102 and say that's 100 plus 2. 100 plus 2 is 102. So by writing it this way, it's the same answer, but I can do this part in my head. So this, using the distributive property, 34 times 100 plus 34 times 2. Well, 34 times 100 is 3400, And 34 times 2 is 68. 3,400 plus 68 is 3,468. No calculator needed. Example number 4. 21 times 101. So again, I can't do this multiplication in my head, but I know that 101 is the same thing as 100 plus 1. So now I've broken it up and I can use the distributive property. 21 times 100 plus 21 times 1. 21 times 100 is 2100, and 21 times 1 is 21. 2100 plus 21 is 2121. Okay, simplifying an expression. So these are not equations. You're not solving for the variable. There are no equal signs. It's just an expression. So we're going to simplify it. This is not the best way for it to look. So here's what you do. Using the distributive property, this 2 outside means it's multiplied by the quantity inside. Even though you don't see a times sign or multiplication sign, the 2 outside of a set of parentheses means we need to multiply. So what you're going to do is say 2 times 5x plus, carry down your plus, 2 times 3. What's on the outside gets multiplied by everything on the inside. So 2 times 5x is 10x, and 2 times 3 is 6. So 10x plus 6 would be the simplified expression. 3b minus 2, this quantity, times 1/3. So we're doing the same thing here as we did in example 5. The 2 was in the front, the 1/3 is in the back. It doesn't matter. You're going to say 3b times 1/3 minus, keep the sign, 2 times 1/3. 3b times 1/3 is just b, 1b, and 2 times 1/3 is 2/3. Example number 7. 6 times the quantity m plus 5. This is 6 times m plus 6 times 5. 6 times m is 6m, and 6 times 5 is 30. So 6m plus 30 is the simplified expression. Let's do a couple together. Example number 8. 2 times the quantity 3 minus 7t. So 2 times 3, keep the sign, minus 2 times 7t. 2 times 3 is 6, and 2 times 7t is 14t. So this is 6 minus 14t. You could also write it as negative 14t plus 6. This is a positive 6, that's a negative 14. So either way of writing it. This is a negative times the quantity 2x plus 1. Well, in front of this is a 1 there. You can't see it, but it's there. So this is basically saying negative 1 times 2x plus, keep the sign, negative 1 times 1. Negative 1 times 2x is negative 2x. Negative 1 times 1 is negative 1. Now, it's not simplified because we have 2 signs next to each other, and you never want to write 2 signs next to each other for your final answer. Plus a negative means subtraction. That's the definition of subtraction. Adding the inverse. So, negative 2x minus 1. Remember, plus and a minus, side by side, become a minus. Example number 10. The quantity 3 minus 8a times negative 1. So 3 times negative 1 minus, keep the sign, 8a times negative 1. 3 times negative 1 is negative 3 minus 8a times negative 1 is negative 8a. Again, I have 2 signs next to each other. Minus a negative means plus. So negative 3 plus 8a. And again, I could rewrite this where the variable term comes first. So 8a is positive minus 3, because it was a negative 3. Combining like terms. Vic number 1, like terms must have the exact variable with the exact same exponent. And we talked about this when we did definition number 4. 5y squared and 10y squared are like terms. They both have y, the variable, and the exponent on that variable is 2 for both of them. 3x squared and 2x are not like variables. Yes, they both have x, but the exponents are different. This has an exponent of 2, and this has an invisible 1. 2 and 1 are not the same, so these are not like terms. Simplify. Example number 11. 3x squared plus 5x squared. So these are like terms. They both have x. They both have the exponent of 2. So we can say 3 plus 5 times x squared. 3 plus 5 is 8. So this is 8x squared. Example number 12, negative 5c plus c. There is an invisible 1 in front of this c. These are like terms because c is the variable and it has invisible 1 exponent, so they have the same variable, same exponent, and we can combine these. Negative 5 plus 1 times c. Negative 5 plus 1 is negative 4, so negative 4c. Example number 13. 7y plus 6y squared. Now they both have y, but they do not have the same exponents. These are not like terms. You cannot combine them unless they are like terms. Now you can multiply and you can divide when the exponents aren't the same. But you cannot add or subtract when they are not like terms. So the answer is already simplified. Example number 14, negative 9w to the third power minus 3w to the third power. So they are like terms, w's and third powers for both. And we can combine these. Negative 9 minus 3. So negative 9 minus 3, put that in parentheses, times w to the third. Negative 9 minus 3 more is negative 12. So negative 12w to the third. And example 15. 8d plus d. Again, remember that there's an invisible 1 in front of this d, just like in example 12. D is the variable, and there's an invisible 1 exponent on both. So they are like terms. We can combine them. 8 plus 1, put those in parentheses, times d. 8 plus 1 is 9, so we have 9d. Writing an expression. So sometimes you're given the problem in words and you need to write it as a mathematical statement. Example 16, 3 times the quantity x minus 5. So the key word here that you've heard me say several times through this video is quantity. It means parentheses. It means something is grouped together inside here. It has to happen first. Remember, in our order of operations, we do what's in parentheses before we do multiplication, division, addition, subtraction from left to right. So quantity means parentheses. 3 times the quantity x minus 5. Now after the word quantity, you see x minus 5. That means x minus 5 goes inside the parentheses. 3 times that, so put a 3 on the outside. Now you can put a dot there if you want, but you should know that when you have just a number outside of parentheses, it means multiply, so that's where the 3 times came from. 3 times the quantity, x minus 5. Example 17, negative 2 times the quantity, so there's that word again, t plus 7. So t plus 7 goes inside the parentheses, and negative 2 times that. So negative 2 on the outside. You could also write t plus 7 with a negative 2 on this side, but then you would need parentheses. Or in the first, in example 16, x minus 5, and you could have put the 3 on this side. Example 18, the product of 14 and the quantity 8 plus w. Again, I see that word quantity. 8 plus w goes inside. The product of 14 and the quantity 8 plus w. So the product of means the same thing as times. So 14 times the quantity 8 plus w. Example number 19. 17 divided by the quantity z minus 34. So again, I have quantity, and this is what goes inside my parentheses, z minus 34. And 17 divided by that. So this means 17 divided by this. So 17 divided, or another way to write it is as a fraction, 17 over, which means divided by. 17 divided by z minus 34, and you need parentheses around that again because it says quantity.